In our study of the relationship between two events and their associated probabilities, we've seen, their simultaneous occurrence, P of A and B. We've seen the conditional probabilities. There's one more that we can talk about, and that's P of A or B. And so the idea is that if we have two events, A and B, I want to know the probability of either one of them occurring. So, well, here would be the probability that A occurs, right? That's in our sample space. There's some probability associated to this happening, right? And then here is the probability that B occurs, right? So we're coloring fun colors, and so we want to be able to say something meaningful about these, and to do this properly mathematically, we need to use, or at least to calculate it, we need to use the principle of inclusion and exclusion. And you can research it, but effectively what it says is that if you can add up multiple things, but if they overlap, at least in probability, you need to remove or add any of those pieces that they overlap in. Okay, so you have to be careful of what you've counted twice or what you haven't counted. Okay, and so if we look at this carefully, I can say, well, I've added in P of A, right? If I'm looking at P of A or B, I've added in P of A. I've also added in P of B, probability of B, so chance of B happening. But then you'll notice that where they overlap, that forms green, and I ended up counting that area twice. So I actually need to remove the overlapped region, which would be the simultaneous occurrence of A and B. Okay, and this is our general addition rule for any two events. Okay, and with this, we can our study of how two events interact is complete. And so if you wanted to, you could go through and label this whole thing. So in here, this is P of A, or this is A and B occurring. This is A not, or sorry, if I call this, I should call this A and this is B. This is B not A. This is A not B. And out here, this is your sample space, not A or B. Okay? Or equivalently, you could say that this is A or B complement. Okay? Because it would be outside either A or B. Okay? And there's different ways you can do that, but just so you kind of have an idea where everything is and how to, talk about these different pieces if you need to. It may be useful in this next and final example. Okay, so here we go. Again, pause the video, read the context if you wish. Okay, so there's some information that's given, and it's talking about, I'm going to use O as the event for older than 65. Okay, and we're talking about I should say, U.S. doctors. U.S. doctors. I should be complete in my definition. Older than 65, and I'm going to say that A represents U.S. doctors actively practicing. Okay, and all these numbers, I actually looked them up. They're all true, which is kind of interesting. But anyway, the information that is given to us is 1 and 4, and then 2/5, and then 2/3. Okay, so if I write this out, I would say P of, okay, is something is 2/5, or 1/4 I'll start with, and then P of something is 2/5, and P of another something is 2/3. Okay, so what is the 1/4? It's licensed doctors older than 65. So this would be P of O, is that. And then if they are older than 65, right? It says 2/5 are actively practicing. So so they're actively practicing given that they're older than 65 is 2/5. And lastly here, this 2/3 are actively practicing. Okay, so there we go. We have our events defined. Okay. For the next one, we want to compute the probability that a randomly selected licensed U.S. doctor is older than 65 and actively practicing. So O and A. Okay. Now this is where we've seen this sort of thing come up, and we want to use that definition of conditional probability. So P of A given O is equal to P of A and O over P of O. Okay, so then this is, 2/5 is equal to P of A and O all over 1/4. And so I can calculate this by multiplying 2/5 times 1/4, which last time I checked is 1/10. Okay, so great, we did that. Again, that's just cross multiplying. And we move on to part C. Part C says, what is the probability that a randomly selected U.S. doctor is older than 65, so that's O, or actively practicing? Okay, now this is where we have to use our general addition rule, which says this would be equal to probability that they're older than 65 plus probability that they are actively practicing minus their simultaneous occurrence, P of A and O. And substituting in the numbers, I get 1 over 4 plus 2 over 5. Oops, nope. 2 over 3 minus 1 over 10. Okay, and then we can do this by hand, right? We can get to common denominators, or we can, find some other method, like using a calculator. And you get, as a fraction, 49 over 60, which is approximately 80 or 0.817. So about 81%, 82% almost, are either older than 65 or actively practicing. So we've answered the question making use of that general addition rule, and that's going to complete our study of extra formulas or extra ways that we can calculate probabilities for two events that are interacting with each other or are independent of each other.